Hello everyone, welcome back to Enginuity Lab. This is part 22 of the CATIA V5 beginner series tutorial. In today's video, we shall learn one of the most important tool, the shell command in CATIA. Shelling is a powerful command used to hollow out solid bodies or solid geometry. A shelling operation removes one or more faces from the solid and apply a constant thickness to the remaining faces. You can apply a different thickness to the selected faces. So let's start. Go to start, mechanical design and part design. Renaming the part as shell. Click on OK. To create a shell, we need a solid body from where we can remove one or two faces. So for that, I will create an object in the CATIA. Select the XY plane, select the sketcher tool. The first one, I will create a simple rectangle. Here, give the dimension. This one is 100 mm. And OK. The next one is 50 mm. Click on the exit workbench. Give the thickness or the height by using the paired command. Here, I will give it to 70 mm. Okay. Now, my dress up tool feature toolbar is activated. Here you can find the shell command or tool. To apply the shell, first select the shell command from the dress up toolbar, and in the shell definition window you can find inside default inside thickness. What should be the inside thickness, or you can give the outside thickness as well. Inside thickness, what will happen, this will remove all the board material from inside and leave it 1 mm from this. If you say default outside thickness, then it will add 1 mm to this face. Means like here this is 50 mm, it will create 52 mm to outside. If I select the inside thickness 1 mm, then the inside length will be 48 mm. So here the another one, faces to remove. Which face you want to remove? Select this one, this one. Now specify the wall thickness or thickness value. And you can select the other thickness value here. If you give this one, this will give thickness, different thickness than others. So let's see and click on OK. Let's see what will happen. Now my shell command is used and created. Let's check what is the inside value of this one. This is 48 mm. If I click on here and here, this is 50 mm as we created previously. Okay. Now my wall thickness is 1 mm here, 1 mm on this face as well, and 1 mm on this face. Okay, this is how we can create a cell. Here in this cell we created, we noticed that we have selected the other thickness faces field HL, but there is no effect of that one. So let's edit. You can see we have selected this face as other thickness faces, and you can see these two faces have only one. This is on violet, and this is 1 mm it's showing, and this face also it's showing some length. This is here it is not showing because these two are same thickness. If I double click on this dimension and change the value to 2 mm and click on OK. Now let's check. This wall have thickness of 2 mm, but this one have thickness of 1 mm. In this way you can control your 3D model. Okay, so let's go and create another example. For that I'll insert another body and right click, define in work object, click on this YZ plane, click on the sketch tool. Here I will create and give a radius here, give a radius here as well. Now I have a profile of a pot, and by using the shaft, now it looks like a pot. Okay, here we are going to use the cell command. Click on the cell, and here I want this face to be removed and the inside thickness is 1 mm. Okay, and click on OK. Now you can see I have a pot which is created automatically without removing the inside parameters. We are able to create a pot. If you want to see, I will make a half section of this, and now you can see the uniformity. The thickness value is uniform all around the profile. So selling is widely used in plastic design, casting, sheet metals housing, and enclosure design. This will help you while creating the working on plastic design, casting, different type of sheet metal housing, and enclosure design. So that's all for the today's session. I hope this helped you to understand how to create hollow components effectively. If you found this video helpful, please like, share and subscribe to Enginuity Lab. Thank you for watching Enginuity Lab. See you in next video.